This section will quickly touch on adjusting conditioning, sprint, and circuit work in the heat. The importance being that these type of activities and protocols are highly demanding. There is large amount of intensity, duration, lots of different musculature used, and prone to generate a lot of heat. So given that, and there is a disproportionately high thermal load as opposed to many other forms of activity, the importance of how do we manage heat, how do we manage body temperature, and how do we program accordingly is important. The adjustments that could or should be made, these are just suggestions in this section, are really going to be dependent on your intent, the goals, the athlete, the circumstances. So everything here is just open suggestion and discussion, but that is going to really come down to what are you trying to accomplish to get the best results for the athlete. So some principles in general, where possible to reduce the density without sacrificing intent. So more rest or higher rest to work ratios, and then implementing cooling where possible during the work or during transitions and breaks. Quality over volume. Shorten the sessions, have them very, very deliberate in what you're trying to accomplish. Also, front load effort in cooler conditions. So if you have the opportunity to look at the environment you're in or to do a lot of the really, really intense work when the body is in a more manageable state, has less thermal stress accumulated. One example may be early mornings or shaded hours or late at night, something to adjust and accommodate the scheduling for the environment. Monitoring, paying close attention to the athletes, and adapting on the fly as needed is also a really great idea. More sprint type modifications, very, very intense. It's going to come down to work to rest ratios as well, cooling intervals where possible, total volume. A lot of the same principles that we see throughout all different types of exercises are going to apply, but they're going to have to be modified specifically to the protocol that's being planned and the athletes you have. Same thing for circuits, AMRAPs, EMOMs. How do you break it up? How do you incorporate cooling? How do you strategize and plan for the environment and this context that's going to have the least thermal burden on the athlete? A few examples here of what an original drill may look like and then what an alternative could be, where you incorporate cooling into breaks, you change the volume, you change the rest ratios. Some of these examples on the right may be on the more extreme side. That may not be necessary. For example, in the sprints to go from 10 to 5 and then to 2.5x the rest time. So it doesn't have to be that much. You got to find the happy medium that gets the best results based on your context and your goals.